Hi, welcome back. So we are at the last assignment of deep learning assignment 2, assignment 12 of NPTL course. What should be the best choice of distribution from which we should sample a latent vector to generate a novel example? So during training, the variational autoencoder VAE P of Z by X is N of OI. Encoder is forced to map its latent code to N of OI. After training is over, we use VAE to generate a model. The correct option is A, that is N of OI, normal distribution with zero mean and identity correlations. Covariance. Second one, when the GAN game, that is generative adversarial networks game, has converged to its Nash equilibrium, discriminator randomly makes an error in distinguishing fake samples from the real samples. What is the probability of belongingness to the real class given by the discriminator to the fake generated sample? So they will be having only two classes here. One is fake and other is the real. So the probability of the fake they are asking, so it is 1 by 2. So it is half. 3. Why is reparameterization trick used in VAE? So answer is B. Sampling from VAE encoder latent space is non-differentiable and thus we cannot backpropagate the gradient during the optimization using gradient descent. Fourth one, which represents the fully variational autoencoder realization? So here the correct option is this one. Fifth one. So which one of the following computational graphs correctly depicts the reparameterization trick employed for the practically variational autoencoder implementation? The circular nodes represent the random nodes, and here the nodes quadrature like this represent the deterministic nodes. The correct answer is this. So z equal to mu plus summation sigma epsilon. Sixth one, for following minimum maximum game at which the state of xy do we achieve the Nash equilibrium state where the change of one variable doesn't alter the state of other variable. So the answer is B, x equal to 0, y equal to 0, v of x y is equal to xy. So if you put both if y is 0 in this, look at here, x of 0, y is 0. So it is a player 1 is going to minimize any value of x is the best. Similarly, if x is 0, player 2 is, that is 0, y is equal to 0, maximize any value of y is best. So 0 0 is a Nash equilibrium because neither player has an incentive to unilaterally deviate. So seventh one, which of the following classes can be used to optimize for the generator's objective while training a generative adversarial network GAN by minimizing without gradient doesn't optimize or consider cross entropy loss? Answer is A, that is cross entropy of 1 d of g of z. This represents the cross entropy loss when the target level is 1 and predictable probability is d of g of z. So this is the formula for binary cross entropy, minus of y log p plus 1 minus y log of 1 minus p. So here y is 1 and p is d of z of z. So minimizing this loss is equal to maximizing the log function. So it is the correct objective for the generator. So eighth one, while training the GAN, which of the following classes cannot be used to optimize for the discriminative objective while only sampling from the distribution of GAN samples by maximizing with gradient ascent optimizer? Cross entropy loss. Correct answer is cross entropy 0 of d of g of z. Okay, so same, maximum loss equal to minimizing the log of 1 minus d of z, which means minimizing 1 minus d of g of z or maximizing d of g of z. This is opposite of discriminator wants to do when the classifying generated samples. So the ninth question, so for training VAE, we want to predict on the unknown distribution of the latent code given an observed sample, that is P of Z by X, but we approximate it with some distribution Q of Z by X, which can be controlled by varying some parameters, which loss function is used as loss to minimize. So loss function is used to train VAE is negative evidence of lower bound elbow. So here this is the equation. So the correct answer is minus of this and this is plus, minus of the whole thing, minus and minus into minus is plus. Correct answer is this. Here it is minus, here it is plus. 10th one, above figure shows the latent vector. So it is a face with the glasses, here it is glasses. So here it is a vector combination. We should have here face without glasses plus glasses equal to face with glasses. So the face without glasses is the correct option. So this is the assignment number 12 with respect to the NPTL course of deep learning subject. So we completed the all 12 assignments Good luck for your exams. Go through all assignment answers and also go through the videos of the NPTEL course so that you will get the answers easily. Thank you. We'll see in the next video of the next update. Stay tuned to this channel for the academic related videos, especially electronics and computer science related branches. Thank you.